All right, apparently I have to start this video with Ruby is cool. Done? Yay, go Ruby. All right. Now she feels good. So looking today at rates of change. So I'm changing this video because the last video wasn't so good. We're looking today at another reason why we're doing differentiation. So up till now we've looked at gradients, all right? And we've differentiated to get a gradient function. So a gradient function describes what is happening to a graph, all right? And the gradient is actually the rate at which the graph's slope is changing. So it is actually a special particular reason for learning how to do this. Now we're expanding it to not just graphs. So real life examples that you'll all use every day, like how is the area of a circle changing if you decrease its radius. That's something you'd use every day out there. But it is the reason for learning things like that, and somewhere out there are lots of people that use it. Don't ask me where. I teach it, so therefore I use it all the time. Okay? So rates of change means that we've got an equation of some sort, and we're trying to find out what's happening with it. So we could have something like the height of a plane can be found using the height of the plane at a particular time is 5,000 metres above the ground plus 2/3 of the time squared. All right? I don't know if that's right or not. Actually, it needs to be a minus to be upside down. Right, minus. Okay, so there's that equation. It doesn't actually matter what that equation is. We don't need to understand it too much. We just know that that's going to give us some sort of thing in metres. All right? In metres. So, if we want to find the rate at which the height is changing, if we want to find the height, what do we do? Substitute, right? Put a number in for t. So, height at 3 hours, so it's measured in hours, equals h of 3, whatever that is. Okay? So that's what it would be. If we want to find the rate with which the height is changing at that particular instant, so instantaneously, we can, if we know that this formula is right, we can differentiate to find it. So, because this is the differentiation paper, it's pretty given that we're going to take, so this is where the dashy formula comes in useful. So 5,000, what happens to that? Goes away because there's no t's. We're differentiating the t, so we're going to get minus 4/3 t. That's the rate at which it's changing. Not by very much in an hour, probably should have been seconds, but anyway. This planes change height quite quickly. Doesn't matter. So what we would want to see is, so what is the rate? The question might have been, what is the rate? Height is changing. When time t equals 5 hours, let's say. So we need to differentiate first and then find h of 5. So minus 20 over 3. And what is it? What's it going to be? What's the unit going to be? Yes, something to do with hours because we're putting hours in, but what are we measuring at the moment? We're measuring height. What does height change at? What does... All right, so it's a changing thing. It's a what do you call it? Velocity, a speed, one of those things. So it's going to have about this. Yes, we're going there later. So that's one way they could ask the question, but there's other ways that they can ask the question. So this is the easiest one. Differentiate, stick in the number, find out what the rate of change is. But what if we've got the rate of change? All right, so this is sort of like, given the gradient, what's the point? This is the same sort of thing. So if the rate it's changing, we're going to keep that changing even though we could write increasing or decreasing, is -7 meters per second. What is the time that happened? All right, so if this was the question, we'd still have this information, and this is the question, then we're still going to differentiate because we are looking at the rate of change. It's our point of interest. So we've got our h dash is equal to -4/3 t. But this time, we've been told that this is this. This is what we have been given. So now we're equating -7 to -4/3t and finding out what t is. All right? How do we find t? -7 times, or 3 divided by -4, right? Times by the reciprocal, or divides by that. You could do that because you've all got calculators. So that's -21 over -4 is 21/4. So that happened at 5.25 hours. All right? So we're going to decide which way we're going as to how we're going to use the information. What have we been given? What are we substituting? What are we finding? But we'll nearly always have to differentiate to find that rate of change. All right?